Good morning, ma'am.
Morning, Assalamu alaikum. How are you all?
We are fine. Thank you.
Assalamu alaikum, ma'am.
Islam class, how are you? Class, do mark your attendance in the chat box. Write your full name along with your class and section. After 2-3 minutes, I will start the lecture, okay? So class, your video must be on because pause on your video as well, okay? Now we are going to, as we already
Assalamu alaikum, ma'am.
class 7 entry,
Assalamu alaikum, ma'am.
do unmute yourself.
मैम आपकी आवाज नहीं आ रही.
Now you're listening to me?
Yes, ma'am. अब आ रही है.
Okay. So class, we are going to start unit 5, gravitation, which we already started. The date is 14 December 2020 and the day is Monday. So the learning outcome for these lectures include students will be able to explain the value of G decreases with the altitude and the surface of the earth. And then you will also able to discuss the importance of law of gravitation in understanding the motion of satellite.
Excuse me, ma'am.
Yes, beta.
Ma'am, some people haven't muted and there are noises coming from their mics.
Do mute yourself, so that's why the other students can listen to you. Okay.
Okay, ma'am.
So class, these are the learning outcomes. Now we are going to start the topic. Variation of G with altitude. So variation is basically the change. G, all you know that this is the gravity. Altitude is basically the height of an object or place above the sea level. So sure, we have discussed the value of G, which is equals to G and E by R square. So class, we have found this value when we have discussed about the topic mass of the earth, right? So equation 5.6 shows that the value of acceleration due to gravity. So class, what is the acceleration due to gravity? Gravity is basically the object's tendency to attract towards the earth, right? So if this is the Earth and there is some object on the surface of the Earth, obviously it will be attracts to the Earth with a value of object is moving downward, then it's mean that it has the body is moving with some velocity in the right. That
Ma'am, I can't hear you.
Yes,
Ma'am,
ma'am.
Yusuf is unmuted.
मैम प्लीज यूसुफ से बोलें ओके मैम अब आपकी आवाज आ जाएगी
okay, class, do unmute yourself. Okay. Actually, I just set my settings, so I cannot unmute you now. Okay. So you have to mute yourself.
Okay, ma'am. Okay, ma'am.
And now concentrate on the lecture.
Ma'am, what is the page number?
Class, do open page number 110. We have started topic 5.3, which is variation of G with altitude. Variation is basically the change, and all of you know that what is the G, right? It is the gravity, and altitude is the height of an object above the sea level, right? So this is the relation G is equals to capital G me by r square, which we have discussed in the previous lecture when we are calculating the mass of the Earth, right? So this G is basically the acceleration due to gravity. When there is an object which is placed on some surface of the Earth, obviously it has a tendency to move downward. So we so as this object is moving downward, obviously it is moving with some acceleration, and the acceleration is downward. So we call that this is the acceleration due to gravity, and this G is the gravitational constant, which we have discussed in the in the Newton's law of gravitation. And this is the mass of Earth, all of you know that. And this is the r, this r is the radius of the Earth, which we have discussed when we calculated the mass of the Earth in the previous lecture. So class, this equation 5.6 shows that the value of acceleration due to gravity G depends on the radius of the Earth at its surface. So this G is basically depend on the value of the radius, right? If we have more radius, it's mean the value of G will be decrease. But if we have less radius, it's mean the value of the G increase. Let's say this is your Earth, right? And the object is placed on the surface of the Earth. Obviously, now this is the R. R must be from the center of the Earth. Now what happened? Here the value of G will be more because the distance of the object and the to the center of the Earth will be is less. But in this case, if this is your Earth and I place object over here, then it's mean the value of G will be decreased because we have changed the position of the object. So this G basically depend on the radius, right? If we increase the value of radius, the value of G will be decreased. But if we decrease the value of the radius, the value of the G will be increased. So both G and R, they have inverse relation with each other. The value of G is inversely proportional to the square of the radius of the Earth, but it does not remain constant. It decreases with the altitude. Plus, when we are talking about the value of G on the surface of the Earth, it is always will be always equal to 10 meter per second, right? But as we increase our object toward the altitude, the value of the G will be decreased. What is altitude? I told you in the start, it is basically the height of an object or place above the sea level. The value of G is greater at sea level than at the hill. If you see the sea level, it is near to the surface of the Earth. So the value of the G will be remain same. But if you move toward the hill and you stand over here, the value of the G will be start decreasing, right? Now, if you come on the next slide, Now the topic is 5 point. Again, we are discussing the topic 5.3, which is variation of g with altitude. Now, if you see the figure 5.5, you have seen that this is the Earth, and Earth has the mass me, right? We represent the mass of the Earth with me, and the radius of the Earth is always capital R, because we take the radius from the surface of the Earth to the center of the Earth, right? So this is the radius of radius of the Earth, which is capital R, and this is the mass of the Earth, which we take as me. And if we place this mass of the body at some height, at some altitude, then what happen? Obviously, the value of the g will be decreased. First of all, we have to check out that m must be on some height with the surface of Earth. So we take this distance as small h. And as this body, which is we present with m, has tendency to move towards the Earth, so obviously it is moving with a force which is equal to w, and w is always equals to mg. Here we take w is equals to mgh. Why? W is the weight, m is the mass of the body, gh is basically the gravity from the height, because here the value of the g must be changed, because this object is at some from some height to the Earth, right? If it on the surface of the Earth, the value, if suppose this object will be over there, right, this mass will be over there, then the value of g will be 9.8. But now this mass is basically on some height to the surface of the Earth, so that's why here the value of the g will be changed, right? So consider a body of a mass m. This is a body of mass m at an altitude h, has shown in figure 5.5. So this is the mass m, and it is placed on some height h, right? The distance of the body from the center of the Earth becomes r plus h. How? The distance of this r is basically the distance of the mass of center of the mass of the Earth to the surface of the Earth. But as we place the object over here, so we have to calculate the total distance. So the distance from center of the Earth to the surface of the Earth will be equal to r. And if we take that this from this surface of the Earth to this object m, the distance must be h. And if we have to find out the total distance, it's mean we will add them, so it will be r plus h, right? So that's why we can say that the total distance from Earth, center of the Earth, to this mass m will be equal to r plus h. So if you see equation 5.6, which is g is equals to capital G me by r square, if we put the total distance over here, this equation will be like this. We first of all we just change the g will be substituted as gh, because this gh is the height of gravity of the object from some height. G is a universal constant, so it will be remain same. And this mass me is a mass of Earth, it is also remain same, but here the value of the r will be changed because the object is at some height, and we have to write the total distance, so it will be r plus h whole square. All right, now so class, this is the variation of g with altitude. So we can calculate the variation of g with altitude with the help of this formula, which is given in equation 5.8. gh is equals to gme by r plus h whole square. Whenever you have some object on some altitude, you have to use this formula to calculate the value of g, right? Now we have equation we have example 5.2 related to this topic. If you look at your book on page number 111, you will find out this example 5.
G, ma'am.
So example is calculate the value of g. You have to find out the value of g. The acceleration due to gravity or at an altitude is 1000 kilometer. The mass of the earth is 6 into 10 raised to power 24 kg. This mass is always remains same because this mass is already calculated, right? The radius of the earth is 6400 kilometer. This radius also remains same because the radius and mass of the earth cannot be changed. So first of all, we have to write the data. We have to find out the value of g, the acceleration due to gravity at an altitude 1000 kilometer. It's mean the height is given to us, which is 1000 kilometer. The mass of the earth, we write over here, me is equals to 6 into 10 raised to power 24 kg. And the radius of the earth, it's right over here, r is equals to 6400 kilometer, right? And we have to find out the value of g, but according to the data, you have no that you have to find out the value gh because the object is placed on the altitude, right? So you have to find out the value gh. On if the object is placed on some height and you have to calculate the value of g, first of all keep in mind you have to use this relationship which we have discussed in the previous slide, that is gh is equals to capital G me by r plus h whole square, right? So first of all, you know the value of g, you know the value of me, you also know r and h. So here they have calculated the r plus h. R value is 6400 kilometer and h is given over here, which is 1000 kilometer. So when you add r plus h, it gives you 7400 kilometer, right? So what you have to do, you have to put the values in this equation and you get gh is equals to 6.673 into 10 raised to power minus 11 Newton meter square per kg square. This is the value of gravitational constant and it will never be changed. It is already calculated, right? And you have to memorize this value as well, right? The mass of earth, you have to place 6 into 10 raised to power 24 kg over here. Then r plus h, which you calculated just now, is 7.4 into 10 raised to power 6 meter whole square. When you are doing the calculation with the help of calculator, you get the value 7.3 Newton per kg, which is equals to 7.3 meter per second square, right? Thus, the value of g, the acceleration due to gravity at an altitude is 1000 kilometer, will be 7.3 meter per second square. Now you know that on the earth the value of g is 10, but as you increase the distance and you move on some height, the value of g is decreased, right? So as we increase our distance from the earth, the value of g will be also vary and most probably it will be decreased, right? Now class, you have, this is your mini exercise. If you look at your book on page number 111, you have mini exercise, right? So you have to do these questions on your notebook as your homework. The first question that is given to you is, does an apple attracts the earth toward it? We have discussed in the law of gravitation about two masses. So we can answer this question. Yes, according to the law of gravitation, gravity is the force of attraction between two objects. All of you know that. That is, here the two objects are apple and the other one is earth. So the apple falls to the ground because it is attracted by the earth, right? The second question is, with what force an apple weighing 1 Newton attracts the earth? So if the apple has a force of 1 Newton, then weight of 1 Newton, then according to which how much force it will attract toward the earth. The force of attraction is equal to the weight of the object. We know that the F is always equal to W. It's depend what is the direction of the object of the force, right? So the apple weighing 1 Newton attract the earth with the force of 1 Newton, right? Because F is equal to W, so the force will also be equal to 1 Newton. Now the third question of this mini exercise is, this is the third question of your mini exercise, right? So this one is, does the weight of an apple increase, decrease, or remain constant when taken the top of the mountain? So class, you can answer very well. If we increase the distance of the object from the earth or we place at some height, at height, place, or in mountain, you can answer me that what will be the value of the g. Obviously the value of the g will be vary because we discussed in the topic of altitude, right? So the value of the g varies as a square of distance. This is the relation. G is equals to capital G and E by R square. The value of g will be the vary according to the, because these g and r, they have the inverse relation with each other. That's why the value of the g will be vary. Therefore the weight of an apple decreases when taken at the to the top of the mountain due to the less gravity of the earth. As the gravity of the object of the earth will be become less at mountain, so the value of the g will be changed, right? So class, you have to do these 3 questions on your notebook as a homework. Now this is the other top side information in your that is given in your book. Value of g on the surface of a celestial objects depends on its mass and the radius. The value of g on some object is given below. So class, all of you know that the value of g on the earth is 10, but if we see the value 10 meter per second square, this is the value of gravity on the earth. But if we see other celestial objects, celestial objects are those objects that are in the sky, like we can say that sun and other planets, Venus, Mars, these are moons, they are the celestial objects, right? So all of you know that the value of g on the earth is 10 meter per second, right? But on the, if we go on the sun, the value of the g will be 274.2. This is written by mistaken, it is only one dot. The Mercury, it has the value of g 3.7. The Venus, it has the value 8.87. On Moon, the gravity is very less, which is equal to 1.62. On the Mars, it has a gravity 3.73, and on Jupiter it has very good means more gravity, that is 25.94. So class, these are the value of g on different planets, right? Now come on the next topic, which is artificial satellite. So class, you can look at your book on page number 112. We are going to start this topic, which is artificial satellites. So all of you know that what are satellites? Satellites are basically the objects that revolve around the planet, or we can say that revolve around the earth. These are the satellite, and all of you know about the satellite because this is a very common term that we use in our daily life, right? So our main topic is artificial satellite. First of all, we have to know what are satellites. Satellites are basically the objects I told you that revolve around the planet. We have the earth, so the objects that revolve around our earth, they are called the satellite. We have the natural satellite, which is basically the moon, because moon is revolving around the earth, so moon is a natural satellite for the earth. Now, what are the artificial satellites? Artificial satellites are those satellites that are made by scientists to get the information, right? So what scientists do, they have made the satellites and they send them into the space, right? And these satellites, they are revolving in a specific orbit around the earth. So the satellites that are made from the scientists, they are basically the artificial satellites. And artificial satellites, why we have made the artificial satellite to get the information. We use these satellite because of for the communication purpose, right? The news we are getting on the TV, the different information we are getting on our from the help of our television or our other social networks, it's because of the artificial satellite. Scientists have sent many objects into space. Some of these objects revolve around the earth. These are called artificial satellites. Most of the artificial satellites orbiting around the earth are used for communication purpose. As I told you class, that these artificial satellites, basically their aim is to provide us the information. So they are used for the communication purpose. Artificial satellite carry instrument or passengers to perform experiment in space. So they are also carry the instrument as well as passenger that are performing the experiment in the space, relating that what kind of information we want to get from them. Now, so so class, if we are as we are talking about the artificial satellite, obviously they need some time to complete their rotation, right? So their rotation varies according to the different satellite. So mostly the artificial satellites take different time to complete their one revolution around the earth, depending upon their distance from the earth. So the satellites, first of all, this is the orbit around the earth, and in this orbit the satellites, they are moving in their particular orbit. So as there are lots of artificial satellites are revolving in our space, so these satellites basically they have different time to complete their one revolution around the earth, depend upon their distance. If they have more distance from the earth, they will take more time to complete their revolution. But if we have, let's say they have very less distance from the earth, then they will be complete their revolution early as compared to those satellites that having a more distance from the earth, right? So we also have communication satellites which take 24 hours to complete their revolution. Means they take 1 day and 1 night, complete 1 day and 1 night to complete their revolution around the earth, right? As all of you know that earth also complete one rotation in a 24 hours. That's why in 12 hours we see the daytime, and in next other 12 hours we see the nighttime. Similarly, the communication satellites, they are also take the 24 hours to complete their revolution. Then we have what is geostationary orbits. Geostationary orbits, basically these communication satellites appear to be stationary with respect to the earth. It is due to this reason that the orbit such a satellite is called a geostationary orbit. So what are the geostationary orbit? We have the geostationary satellite basically, and if we see them from the earth, they seem us to be stationary. Why they are seen to be stationary? Because they are moving with the same distance as our earth is rotating. If we see with the respect of our earth, these satellites shown us as stationary, but in real they are moving, but their motion is along the as the rotation of the similar to the rotation of the earth. As the earth is rotating, they have also same rotation with the earth. That why if the scientists they observe these satellites from the earth, with respect to earth, they seem to be stationary, but in real they are not stationary, they are moving along the earth. That's why we call them, they are the geostationary satellites, and they are moving in the geostationary orbit. So dish antennas, you all know with this, from they are sending and receiving the signals from them, have fixed direction depending upon their location on the earth. So in geostationary orbits we have the dish antennas. With the help of dish antennas you can send the information, and we can also receive the information in a form of a signals. These are signals, they are basically in the form of waves. Through this we are getting the information, and they are having the fixed direction which depend upon their location on the earth. Now these are the side information which are given in your book. First of all, we see that do you know. So the height, do you know the height of a geostationary satellite is about 42,300 kilometers from the surface of the earth. And they told us about the height of the geostationary satellite, which is 42,300 kilometers from the surface of the earth, and the velocity with respect to earth is 0, because they are moving with the same velocity to the earth. That's why they have the 0 velocity, and they are shown us as a stationary objects, right? Stationary satellite. Then we all know, you mostly use it from GPS, which has abbreviation Global Positioning System. It is GPS is also basically a satellite. It helps us to find the exact position of an object anywhere on the land, on the sea, or in the air. GPS consists of 24 Earth satellites. These satellites revolve around the Earth twice a day with a speed of 3.87 kilometers per second. And with the help of GPS, mostly using your mobile, and you find out the location. So these GPS are basically the satellites that are giving you about information about the map, right? So class, the time is going to be out. So if you have any question, you can ask me, okay? Or because we are going to end the lecture. If there's any question, you can ask me. Class, if you have any question, then tell me. Otherwise, I have to end the lecture.
मैम हमने होमवर्क में सिर्फ मिनी एक्सरसाइज ही करनी है
Yes, you have to do the mini exercise as your homework. These are the only 3 questions.
ओके मैम
मैम आप मिनी एक्सरसाइजेस को जीसी में पोस्ट करेंगी?
I will upload this same lecture on GC, so you can write these questions on your as well.
Okay, ma'am.
Class, is there any other question you can ask me?
No, ma'am.
So class, if question we can yes, beta? There is no question.
मैम कैन वी लीव नाउ
Yes, you can leave if you have no question.
Allah Hafiz, ma'am.
Allah Hafiz.
अल्लाह हाफिज मैम
Allah Hafiz.
Allah Hafiz, ma'am.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz, ma'am.
Allah Hafiz, ma'am.
Hafiz, ma'am.
अल्लाह हाफिज मैम
Allah Hafiz, ma'am.
Allah Hafiz.
Allah Hafiz, ma'am.